sure that every one of us in the classroom, if you sit now, I don't think you will focus 45 minutes constantly. Your mind will go here and there sometime. I don't think. If it doesn't go, that means you are abnormal. Okay. So that is called acute loss of memory. It is sometimes really not loss of memory, it's just not focusing on certain things. Okay. Whereas here, this is a progressive loss of memory chronically. What happens here is that, in the brain there is a cortex and medulla. But there are neurons in the cortex, and those cortical neurons are lost or die. Death occurs. In fact, if you take a slice of the brain in Alzheimer's disease patients, also, you cannot take the slice of the brain when they're alive. After they die, you can take the slice of the brain. And if you take the slice and really look at the brain slice, what you see is nothing but tangles. There are what are called tangles. These plaques are there, which is dark-looking structures in the area, which are in fact covering the cortical neurons. Okay? And because these tangles cover the cortical neurons die. The moment the cortex is not functional, I'm sure that you saw the original pictures of what's his name? Eric Kandel from Rockefeller, who won the Nobel Prize for memory and other aspects. What he showed is in the cortex, if you take electron micrographic pictures, there are what are called extreme small dots, dots are there. So depending upon where the dot is, you can tell that that area is the memory area. And in fact, several times you remember certain things long time ago, but then sometimes you don't get the information back. There is only so much to write. On the chalkboard you can write so much information, but you have to erase the information to put some more information. Same thing. The cortex is loaded with a lot of surface area to etch these things, like spots, small spots are being etched. But those etched spots, obviously, you have to remove certain information to put new information back. Okay? But that is a normal process of memory. There are what are called long-term memory and short-term memory, all those things. We don't want to go into the details there. But nevertheless, what happens here in Alzheimer's is that the area where the storage of information is there, that's why the cortical neurons are blocked and death occurs in those areas. And that is by, what is it called, beta amyloid plaques. Okay? What are beta amyloid plaques? These are just nothing but beta amyloid protein, which is cleaved by another protease. And the protease cleaves this beta amyloid protein and generates a beta cleaved peptide. And they think that these peptides are extremely important for death of these neurons, but nobody still knows the mechanisms of how these things are killing these neurons. But if you take a look at what types of disorders are there in Alzheimer's, there is 3 autosomal dominant forms. One of them onsets after 60 years. And in this case, the familial aggregation is lambda equal to 4 to 5. Again, monozygotic is 50, dizygotic is 18. So there are also environmental factors which are playing a role in this disorder. But unfortunately, the risk of this loss of memory or dementia is called. If you take a look at 65 to 80 years old people, look at the male to female risk of development. Risk of development of Alzheimer's disease is about 12 in female compared to 6.3% in males. Whereas 65 to 100 years, it is more or less the same in male and females. Okay. Whereas if you are less than 80 years, more male, females seem to develop the disorder. But whereas any dementia, not only Alzheimer's, there are multiple disorders where memory loss can happen. If you take those things also, females are unfortunately affected more than males, whether it is 80 years or above 80 years. Still, female percentages are a little bit higher. But in the recent years, there is one remarkable correlation with ApoE protein. This ApoE protein is a component of low-density lipoprotein complex. you have in your bloodstream, I mean, if you eat your hamburger in the morning, half hours or something like that, if you take your plasma, you will see nothing but yellow gooey stuff everywhere. And those are your whatever goes into your system, right? And therefore, anytime it goes into the gut, and they form what are called chylomicrons, and get absorbed, and particles go there. But there are what are called HDL and LDL particles, which will take up these things and make them utilized. That is what the purpose of these LDL and HDL are. But if you have LDL particles in much, much higher prevalence, it is called bad cholesterol. HDL is a good cholesterol. So this ApoE is one of the components of LDL, which is bad. So in general, all these LDL things will just obviously interact with the liver receptor, and the liver is the one which clears these cholesterol. And ApoE has been found in these brain plaques in Alzheimer's disease, and that is actually binding to the peptide that is released to the beta amyloid protein. So whatever this beta amyloid protein, when it is cleaved by the protease, is going to generate a peptide called A beta. And that A beta interacts with ApoE. Okay? But then in the population, they found different alleles. 3 alleles were found. There is F1, E2, E3, and E4. If you take a look at this particular table, forget Japan, just let us talk about the United States. This Alzheimer's disease, if you have these alleles, look at here, E4, 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 E3, or E4, E2. Here, in this case, there is no E4 at all. Whenever there is an E4 allele, whether it is heterozygous or homozygous, it doesn't matter. You have a higher prevalence of Alzheimer's disease. So that means there are some alleles of these. Obviously, some mutations are there in the alleles which are making it distinct different from E4, from other E3 and E2. So these are the same table put in a curve form. Particularly, if you take a look at this E4 allele, which is homozygous, and if you consider at the age of 80, how many people or proportion of people unaffected? The unaffected people at the age of 80 for this is extremely low, very small, maybe about 5 to 10%. Whereas if you take a look at 2 and 3, that is 2-3, that is allele 2 and allele 3 combination. At the age of 80, you almost have 0.8, 80 to 90% of them are still being unaffected. Okay? So this kind of age distributional curves, I mean, they have this curve is very simple, but it took them a lot of time because they have to collect all the people of those Alzheimer's patients. They have to age groups precisely and get these curves. It's a lot of work, particularly clinical work. There's a tremendous amount of clinical work. And obviously, this particular work has clearly demonstrated that the so-called E4 allele is obviously associated with Alzheimer's disease. Okay? In addition to these genetic disorders, we have congenital malformations. The classical ones are neural tube defects and congenital heart malformations. Let me give you this particular figure. In this figure, what you're seeing is initial structure of the embryo, how it develops in the initial stage, okay? What you're seeing on the top of the figure is, if you take the embryo, you have got the head, a little bit of the tail area, and there are a lot of somites, okay, segments are there. And that's what exactly is being shown here. Those small circles in the middle are the somites, and there is the interior end, that is the cephalic end, and the caudal end of this the embryo. But there is what is it called a neural groove. In general, when the embryonic development starts with the root structure, and then neural plate and all those things will come. Okay? So in this neural groove, if the defect is in the anterior tube of the neural groove, what happens is that the entire head area or the brain area is completely not developed at all. So this is, if you take a look at this head of this particular person, absolutely there is no brain in this area. Total brain is lost. Very small amount of the brain may be there, but 90% of the brain is not there. That is called anencephaly. Okay? Whereas if you take the other end, and then there is a defect in the closure somewhere in the three areas. One is called neural tube caudal to the lesion, and then there is a meningomyelocele, that will give you this, and that is the area which will be there, and also spina bifida. Okay, there are three kinds, wherever depending upon where exactly the defect is, the morphological defects. Okay, so these are all the neural tube defects that you have. So in anencephaly, you got a forebrain, meninges, the wall to the skull, and the skin are essentially absent. But these children are still born. They are not really alive. But this is a congenital malformation. In spina bifida, the failure of fusion of arches of vertebrae. Okay? Don't worry about, there is another spina bifida occulta. Okay, that is just a minor modification. So mostly all the neural tube defects are all stillbirths. Okay? If there is occasionally there is a survival, totally handicapped. Pretty difficult to go through. But most of these causes for these congenital abnormalities are not, mostly single gene defects are there, but particularly what are called amniotic bands. What happens when the fetus is growing, some other extraneous structures like placental and other things can actually push the embryo. It is like if you take a rubber band and push your finger out, what happens? The blood flow stops and all sorts of other things are there. And those are called amniotic bands. And obviously, it could be chromosomal disorders, which we talked about before, lots of other things. But one fortunate thing happened in the research program. There is what is it called a folic acid. And people who are pregnant, if they are given folic acid supplementation, of course, this is not going to treat 100%. Folic acid supplementation will reduce the neural tube defects. Therefore, it's not like 100% of the cases, okay? So what people observed is, suppose if you have, let us say, neural tube defects are 100% in a population. If we take folic acid supplements in the pregnancy, from 100% it dramatically dropped down to maybe about 40%. That doesn't mean, that means it's 40% cannot be treated by that, but obviously 60% can be treated, okay? That's all it means. So this slide tells you where exactly this folic acid really acts, and you can go through the pathway with the biochemistry, there's nothing genetics here. And the cleft lip and the cleft palate. This could be either syndromic or non-syndromic. I think we defined what is a syndrome. What is a syndrome?
Several
Right. Suppose if there is a big gene deletion, you can get multiple types of defects, not just one particular disorder will be there as a syndrome. So in this case, it could be syndromic or non-syndromic because cleft palate, where else it will come? In trisomy what? You answered that question.
13 or 19?
13. 19? We only talked
I
about
don't
18.
know. Thinking 18.
I don't think it's 19. So syndromic are obviously Mendelian single gene chromosomal like trisomy 13, etc. Right here it is. And non-syndromic, non-Mendelian single gene, mostly sporadic. There is a familial aggregation, which means the lambda is going to be a pretty high value. A recurrent risk